And good morning on this lovely Saturday morning live from London. And thank you again for joining me. It's almost the holidays, so this is going to be, hopefully a fairly light broadcast. We're going to cover some of the 4Clojure exercises and have some fun learning some of the core stuff of Clojure and some of the core Clojure functions, and again, just thinking in a functional way in Clojure as well. And let's see, I'm going to just start sharing my screen for a second. Okay, and then we can get started. There we go. Wee, trippy. There we go. So what are we going to do today? Yes, so 4Clojure. So in the previous video, we did, in the Meter-Mentored Group, Study Group 3, we did cover the first 15 of the 4Clojure exercises. Again, those are all fairly straightforward, fairly short exercises anyway. If you kind of have the basics of Clojure, then they're very trivial, they're elementary, but if you're just starting with it, they're a good place to start just to get some comfort level up with Clojure as well. So we're going to start from 16 onwards, and we might do most of them sequentially as well. So there's maybe 15 to 25. Oops. And if we've got time, we'll do a few more meaty ones as well. Oh, there we go. I wonder what the meeting is. There we go. Let's get rid of Slack for a moment. There we go. Okay. I was going to do the advent of code, but as you can see from my login, I haven't actually got very far yet. So I've still got exercises to do. There is, if you are interested in the advent of code, then you go to Twitch, Tim Coates. There we go. So Tim has been doing the advent of code on Twitch, so it's twitch.tv Tim Pote. And there's a whole section of videos like day by day. He's been going through each of the advent solutions to advent of code and explain them in a lot of detail as well. So I'll also be going through some of these videos. So it's definitely one I'd recommend going and having a look at as well. So let's go to 4Clojure. And so I always recommend logging into 4Clojure, and so you can go in and create a free account, and then it'll track all the solutions you're adding into it, so it'll remember. So I've got a solution there, which we'll have a look at in a moment after we've walked through the problem. But it'll keep track of it, and you can also, once you've solved the problem, if you follow the top users, so it lists kind of like the top users in terms of how many people, how many exercises people have completed, then you can also see their answers once you've solved, or once you've come up with a solution to the problem. Then you can go and see, if you go in and click follow on these people, you can go in and you can go and see their solutions as well. So there's people like Mike Fikes on here, who does a lot of ClojureScript stuff. So there, if you see people you know, they're always good to follow. And I'll add some recommendations of people to follow in the comments in this video as well. So let's go back. Okay. And hold on just a second. Before we start, I'm just going to bring up the chat window. Yes, last week I forgot to, I got so involved in the problem, I forgot to look at the questions that were being put in the chat. So I'll try and keep a better eye on the chat questions. So if you have any questions, you're watching the broadcast live, feel free to ask questions, and I will try my best to answer them as we go along. Let's just bring up my channel. And that's me there. Oops. There we go. Right, I can see the live chat now. Okay, so let's have a look at problem number 16. So hello world, so it should be fairly easy, you would think. The difficulty level here says it's elementary. So we've got, it's asking us to write a function that returns a personalized greeting. So we need to put in a function in here. It's going to take an argument of Dave, and then it's going to return hello Dave. So we should be able to do that fairly easily. I'm just going to copy this into my editor. So what I normally do is just go in and copy the text and put it into the editor. It's my editor that's set up for Clojure development. And I do have a 4Clojure file that I'll share as well. It still needs a lot of tidying up. I'm trying to explain how I've kind of the thought process of how I've gone through solving these, especially the larger exercises as well. So I'll start sharing that on GitHub as I tidy that up. So we haven't done, we've done 18, so we can have a look at that when we get there. So let's have a look at 16. Little divider, number 16. 16, there we go. So it's difficulties, no topics, we get rid of that, and then keep the description. Let's just comment these out. So I'm just selecting V, and I'll highlight everything, and then just GC will comment things out for me. Base max, and let's tidy up this a little bit. Right. So how do we solve this? Well, how do we create hello Dave? Let's just start with the first one. So if we simply use the string function will join things together, one or more arguments, and make it into a string. So this is like using the toString in Java and C# and languages like that. And so it's basically concatenating things together. So if we did hello, so we do hello, and then comma, then we would need to take another argument. So if we had another argument of Dave here, this is kind of representing what we would kind of do. So we'd need a function that would pull in Dave as an argument. So let's just like hard code it all for us to start with. If we evaluate this, does it give us the right results? Let's have a look. It almost does. String doesn't include any extra spaces, so it does exactly what you say ask it to do. So here would need to add a space. Hello. We can't change Dave because it's going to be an argument here, so we need to make sure that whatever initial value we're giving, then we're passing that today. We're including the space in that placeholder we're adding. So now if you evaluate this, this is a comment. So it gives us the right result. So that's kind of the form we want, but we want to write this as a function that we can basically insert into this piece of code here. And so we could write functions. So we use a function command. It's going to take an argument. So we define our arguments in square brackets. And let's say person to give it some context. And so it's going to take person name. And it's going to basically call string and then do hello, comma, space, and then person name. And so that's an inline function that we can call. And if we evaluate that, we just get the reference to the function. So then we obviously need to, so that would work. That should probably work in here. To test it, let's test it. So we need to put it into brackets. So if we Hello, pussycat. Food. You got food? Come on. There we go. A little visitor from France. There we go. So if we have this expression already, we want to put our function in there instead of the dash dash, get rid of the dash dash. So this is our function definition. This is our function call. So if we had a name for this function, we'd actually, and we made this a defin, we could then just use the name in here. But here we're just being very explicit and including the function definition, and then wrapping that function definition inside a list. So that makes that a call to that function. And then we have the argument that we need to pass into into that function, Dave. So we should be able to run this now and get a result. Hello, Dave. So that looks very promising. So we should just be able to put in this function person name as the answer to this problem. So let's go and have a look at that. So let's copy that over to the browser. I do believe I do have a solution already, which is a slightly different format. Oh, and I've also missed something. Yes, there we go. I missed something on the description of the challenge. So this isn't going to quite work. Let me just copy. Oops. Just copy this. So that's the actual final answer I came up with. Let's just put that down here for safekeeping. We'll come back to that in a minute. Because what I've forgotten is that actually this Dave has got a question, like exclamation mark at the end. So this isn't quite going to work. It'll run, but it won't give me the right answer. So I've put the code in. I'm just going to press run, and it starts executing the tests. And you see it's failed because I've not. It's not very useful kind of error message here or feedback here. Doesn't tell us why we're failing the tests. So that's why I like doing it in the editor in my my Spacemacs editor, because that way at least I can see what the result is and I can compare what I'm getting by putting this into the overall expression. And so we can see that rather than just person name, we also need to add the exclamation mark. So we can, string will take multiple arguments, so we can just add this into here. So let's do colon and question mark. There we go. And so there's no space between the person's name and the question mark, so this will just join up correctly. And if we do the same thing for our actual function call version of this, let's just paste that in there. And when we execute this, we should be good to go. So hello, Dave, and now it's got the question mark in there. So if we go in and put this function in, copy paste that, and let's just update this with the new version. And then when we, I'm just going to hide that out the way, there we go. Oops. And then when we run, then hopefully our tests will all pass. There we go, or all green, green, green. And it says we've got a golf score of 43. That just means basically how many characters we've actually run. And it's oh, there's
morning, John.
There's somebody on the chat. Good morning. How are you doing, Manny?
All right. Sorry, I'm a bit late. Just got tied up, but you've started, which is a good sign.
I've already started. Yes. Yeah. So I'm just doing the first 4Clojure exercise.
Oh, okay. Have I missed a whole lot, or is it just?
No. You haven't missed anything at all, really. So I've just been explaining how to solve this. We're basically wrapping this string function that concatenates things together to form a string, like you would do with toString in other languages. And then to make it work in here, we're just putting a function into, we're just wrapping it in a function.
Okay.
And this is giving us a golf score of 43. Golf score is kind of like is not a massively serious kind of a view. You can see basically how short your score is compared to other ones. So I've got a golf score of like 43, but I've also kind of got it so it's a lot shorter. So it does allow you to kind of look at different ways of doing it. Sometimes a lower score is a good thing, and most of the time it's not really that relevant. It just shows you there is alternative ways to do things, perhaps, and sometimes people cheat as well. So it's it's not always the most elegant code if it's the shorter one. And we can also see other people's solutions as well.
Which side are you on, John?
I prefer readability over shortness, because the computer doesn't care, but the developers do. Developers definitely do care about reading code, and if you don't want all your teammates or yourself to hate you for writing bad code, then just try and make it as readable as possible. So I've got a solution. So let's look at the code. And is there anything I could do to make it shorter? I mean, it's an interesting question. Can I make it like more make it shorter without making it less readable? Well, briefly showed you the previous answer I did. If I jump back to the code editor, so I can actually use the short form of the function definition. So here we've got function definition using function, and then we put that into a list so we can call it. We can do the same thing with here. So here we've got another function definition. So instead of doing fn, we're just using this hash with the round brackets. And that's the same. That's equivalent of function. So if I've got a function that takes an argument and then does some behavior, there's just 3 commas there. 3 commas are white space. So I'm just using that as a placeholder for where I would actually do the behavior of the function. That is the same as doing hash, and then So those two are kind of those two kind of expressions are equivalent.
How are you going to use the second one if you don't give it a name?
Well, neither of them have names. I can't include a name in here. But when we're just defining things with fn, or the short form of fn, then we are doing this to run these in line with code. So we're not going to. They're not shared between they're not shared within the namespace. They're just in line.
Like the parameter would go outside the brackets.
Well, they're like an inner function essentially. So
I see the previous line. Yeah, I see line 22, 23.
Yeah. So here we're actually calling it directly. So rather than having a defen name, then we're just having it. We're just expressing it in there. And sometimes you want to shorten that out. By shortening out doesn't make it any less readable. So here it's just stripping it down to the bare essence of what the function is. So if we compare line 23 with line 29, then we can see that string hello, we're doing the same thing. The only difference is instead of person name, we've got this %, which is which represents the argument you're passing. And then we're going to add the character. Here we're just adding the character quote, but we could do that's probably because to get the lower golf score. But if we just do these double quotes, then it makes it similar to, it makes it the same as the function definition that we've used as well. So now these are equivalent. The only real difference is this %, and that's that's the kind of the person name that we're pulling in. Yeah, so this is how you represent the argument that you're passing to this function. So again, you would need to call this function because this is a function definition. So we do control. If we call this to call a function, then hopefully we've learnt by now that we need to do that inside a pair of round brackets inside a list. And so then we can paste our function in there, and then we need to supply an argument of our person name. So let's do Manny, since Manny's on the call there. And so now this should return the same results for Manny. So it does the same thing as this hello person. It's just a slightly shorter form. And again, it's still fairly readable. You do need to get used to this syntax, obviously, which can throw you at first, and then this % sign as well. You can also do %1 and %2 if you've got multiple arguments, so on and so on. You can do as many as you want there as well. So % and %1 can be treated the same. But usually, if there's only one argument, then you just do % is quite common to use as well. So that's solved that one. So where are we? Yeah. So if I put this into,
I got a golf score of 28.
Oh,
no, sorry, 43.
Yeah. So 43 I got with this function here, and then if I do this and run it again, then we'll get a slightly lower golf score. The golf score again is just showing you how many characters you've got. So I've got a golf score of 17. If I change this from I change that from a string, and I can just quote it as a symbol that doesn't exist. So if you put a quote in front of something, it just says just treat this as data. So it's not going to try and evaluate it. If it was just that or just like a name here, then it would treat it as a symbol, and it would try to evaluate it. So if you had like a value that was represented by a name, it's like if you had the name 5 that pointed to a value of 5, then if you wanted to use that, then just as the name itself rather than the value it points to, then you can use a single quote, and it says just treat this as a piece of data. Don't look underneath at what 5 points to. You can just use it as a symbol. So to get a really low golf score, I can do the same thing with question mark. Question mark doesn't really have any kind of semantic meaning in my code. So I'm just using it as a piece of data, and I think that should still work. But normally you wouldn't do that in code because it's a bit cryptic. It's like,
how have people managed to get scores lower than that? Like, what did they even put in as the solution? I'm curious.
That's a good question. Yes.
Because if you see the bar, there's some couple of them that have got lower bars than that.
Yeah, I'm sure there are other little tricks. So yeah, most of these people use that kind of the short form of the function definition, which should be quite common to see. I don't know if there isn't really anything any short. That's right. Okay. Oh, interesting. So here somebody's specifically using the clojure.string to join things together, which is perfectly valid, I guess. So this is using an extra, rather than using Clojure core, we're using Clojure.string, which has got a lot of really interesting functions for working specifically with strings. But we don't need anything particularly like that for this, because the string function in Clojure core just works very nice. I can't see anything that's really any shorter, so I'm not quite sure how anybody's done it, unless it's counting some of these things that were solved before 4Clojure started scoring solutions. So there might be the odd trick there, but I think if you made it any smaller than this, then it would just be so cryptic you would wonder what on earth you were trying to do as well. So I wouldn't worry too much about the scores. I mean, so long if you're way out of if you've got a score of like 300 and everybody else has got a score of 20, then it's an indication that it's probably worth looking at the solutions to see other ways of doing it. So I think this is just a very rough guide of whether you've come up with like a quite wordy solution compared to everybody else, or a kind of a more tighter solution, and if you've done a solution of 10 and everybody's got one of 30, well, then maybe your solution is too cryptic. So it's but it's a very rough tool to kind of judge the quality of a code with. So that's 18. No, that's 16 even. Let's look at 17. Any questions on the thingy? No, there's a couple of people saying, hello, programming is amazing. Hello, programming is amazing. I have to agree, programming is amazing.
No questions for you, John. They're being nice to you because it's Christmas, pre-Christmas.
They're not asking me hard questions, which is good. Well, these are all elementary stuff, so hopefully, if you've done a little bit of Clojure before, you find them fairly easy. And if you're new, then hopefully you won't find them too challenging. This one's interesting. This one's talking about how using the map function, which is a very commonly used function in Clojure. So map function is going to take another function as an argument, which is this one. We've already seen this short form of defining a function. So this is a function that's going to add 5 to something, to whatever argument we pass. It's just simply going to add 5 to it. And the nice thing about map is it will take this function and apply and use it with each each value in this collection. So map will go to the collection and say, okay, I'll get the first element, and then I'll pass that element to this function, and I'm going to get the result, and then I'm going to keep that result safe while I then go off and get the next value, which is 2, and then it's going to pass it to this function again as another argument, and so on until it's gone through the entire collection. So it's a really handy way to iterate over a collection with a specific function. So you can do things, you can do simple things like, let's see, so let's do, this is number 17. Yeah. So let's add a divider. So this is number 17. And oops. If we've got map, say we want to just increment the values in a collection. Oops. There's our collection 1, 2, 3. Then if we evaluate this, then it's simply just going to apply in turn the inc function to each of the values in the map, and it's just going to each of the values in the collection, and it's going to return those values. So we can see here it's going to take 1, it's going to turn that into 2, 2 is going to turn into 3, 3 is going to turn into 4, gathers up all those results and returns them as a collection as well. So map's quite a really handy tool for basically updating and transforming a data structure in some way. And you can also do multiple data structures. So you can do map, say we want to add all the values that are in 2 different collections, 1, 2, 3, and 3, 4, 5. Add those together. So what map is going to do is it's going to take the value from the first value from this collection and the value from this the first value from this collection, and it's going to pass them to add and keep the results, and then move on to the next one. So the next one, it will get the second from there and the second from there, and so on and so on. So we should get each of those values being added together. So 1 and 3 is 4, 2 and 4 is 6, and 3 and 5 is 8. So if we go back to our problem here, let's just copy that. We've got the answer there already. You might have spotted. So yeah, we just basically have to supply the resulting values in this.
Can we not just put the result there, which is a sequence of like 3 numbers?
Yeah. Exactly. Yeah, that's the simplest answer. Yeah.
Yeah, because you don't need to do a map, right?
No, the map is already what's there. So I was just explaining what the map actually did, how map actually works.
Yeah.
Yeah. So in order to solve this, you just need to understand what map is going to do So instead of providing the mechanics, the logic of this, you're actually trying to understand what it's doing and provide the result, essentially. So if you were going to if you're going to write this as a unit test, then you'd actually you figure out what the value is you wanted to return, and then you'd write the function, or you'd call the function that actually provides those results. In this way, we're doing it the other way around. We're reading the function, and then we're trying to figure out what it does, or just running that in the
REPL.
In the REPL, yeah.
I noticed it doesn't count spaces, which is a good thing.
It doesn't count extra spaces, yeah. Yeah. So yeah, so here, if we go into map 5 over to each of these, so then we map 5 over 1, we get 6, 2, we get 7, and 3, we get 8. And I'm putting that in as a vector. Or you could put this in as a map as well. Sorry, not a map, a list will work as well. Although, if you're going to do it as a list, then we don't want to call 6 as a function, so we'd have to use the quote to do that as well. And if we do it this way, obviously we're increasing our golf score by 1. So instead of, so I should get a golf score of 5, but I get a golf score of 6 because I've got an extra character, essentially. So typically, if we know we're just dealing with data, then we'll put it into a vector because it's just easier to work with. And also, we might want to do some random access as well. One's a pretty simple one, so golf score 5, and the solutions, I don't think there'll be anything particularly interesting there. Somebody might do, yeah, they're all pretty much the same. Yeah, you can, yeah. Somebody's literally
just put the same one back. That's cheating. That's not learning anything.
Yes, that isn't. So you have to take some of these answers with a pinch of salt. Oh, that's quite interesting.
I like the range one.
That's a bit of logical thinking. Again, it's considering what the answer is and trying to generate the answer.
Yeah.
So that's quite novel. Yeah, and there's quite a few different ones there. So. Oh, interesting. And then this one's range. So range would return a list, and then it's just putting it in as a vector. Again, there's no real need to do that because it doesn't matter whether it's in a list or a vector in this sense, because it's just comparing the values and it's not comparing the type of data structure. So you don't need to worry about whether this is in a map or a list. It doesn't make any difference so long as the values themselves are correct. And that's the same with a lot of the Clojure. It's usually comparing the values. It's treating these collections as what it calls a sequence, and all it really cares about is the values that are inside this the collection, the data structure. It doesn't really care about the type of data structure itself in the main. Certainly, if you want to do extra things like random access and so on, that you start thinking about using different collections. Okay, so let's do 18. I think I've already done that one as well. So let's have a look. Let's just make this a little bit bigger, just in case. This sequences. So we're still doing sequences. I hope you didn't see the answer too quickly. And this is not that dissimilar from the previous exercise. So instead of map, we're using filter. But the same kind of logical approach to how this works is the same as map. So map applies a function to a collection, so does filter. So filter is going to take these values and pass them to this function. So it's basically going to filter out anything that doesn't satisfy this function. So if this function returns true, it's going to keep that value. So if it goes in and that filter returns true, it's going to keep that value. If it's false, then it's going to throw that value away. So yeah, as it says, filter takes 2 arguments: the predicate function, this function that it's going to use, it's going to apply over each of the elements of the collection, and the collection itself. So it's basically just saying which these values are greater than 5. And so then that's fairly easy. We can just return 6 and 7 either as a list or a vector as well. So that's pretty straightforward. But these map and filter and reduce and apply are very powerful ways of processing and transforming data from one structure to another. So that's pretty simple. Did I do anything? I think I've already got that in my file. Yeah. You can do. Oh, is that a different one? Oh, that's a different one. I've got the. Oh yeah, that. Okay. And 19. Let's go to 19. So I'm just updating the numbers. That's the easiest way to jump between these ones as well. So some of the challenges are a little bit tricky because they have these special restrictions. So this function, the solution to this last element, the key, like the clues in the name of the challenge, is that I could use the last function in here, and it would just be the solution. But I'm not allowed to use last, so I have to actually think about how the last function actually works and basically implement my own my own function that will do the same thing. So that makes it a little bit trickier to solve, because otherwise this will be like a 2-second solution.
You can do it with cons and what's it?
Cons and what's it?
What's the one that gives heads and tails?
Oh yes. What is the one that gives heads and tails? Oh, you mean first and rest?
Yeah, first and rest.
Yes.
Sorry, I was thinking of scheme for some reason because it's called something else in scheme.
Number 19. That is a bit. Oops, what's it doing? Go away. Yeah. No. Oh, yeah. I'm having Sunday morning brain freeze. There we go. There we go. So how are we going to solve this? Well, we could, yeah, as Manny says, we could use first and last and do a little loop through the code, and yeah, just writing a little loop thing that will basically, or a function that calls itself, which will basically work through all of these until it gets to the last thing in the sequence, and if the collection is empty, then we can return that. So we could do something like a loop, and then our call, which is the will be this case space that. And then we could simply do like a if empty call, and we need some kind of accumulator. We need kind of like to keep a track on what was the value. It's not an accumulator, so it's like the current.
John, are you looking for a long goal score or a short one?
This is going to be a long one. There's a short. I do know there's a short way of doing this, but I'm just saying this is kind of like the lowest level of abstraction of using Clojure.
Yeah, got it.
And this may or may not work entirely, but this might be a little bit of pseudocode. So if the collection's empty, then we processed everything. So then we would just return the current val. So that would be the last value that we looked at. So we'd probably set that at like 0 for now. And then we would, and if we're it's not empty, then we would then recur. And I can, Manny, when you're eating, could you put yourself on mute? Because then otherwise we can all hear you eating. Thank you very much. And then I recur, and then we pass back the rest of the call, and then and we'd also need to set the current value. So we would have the first of the call. So this would grab the value. I don't know if this would work, but that's kind of roughly what we do. I don't know. What does it do? Is it? Oh, there we go. 5. It worked. Amazing. I'm impressed with that, actually. Yes, there we go.
I'm impressed how you can write a lot of code, John. It's Clojure, and you still wrote a lot of code.
Yes. So this is the very long-winded, the very explicit way of doing things, and this is kind of, it does feel kind of imperative kind of approach, because you're defining exactly what it's doing. You're defining that you're going through an empty collection. It's not too bad. It's kind of, yeah, it's fairly Clojure-y, but there are better things that we can do. There are more elegant things we can actually do in this kind of thing. But if nothing else, this works. It does what it says in the tin, and it kind of gives you some idea about what you need to do. But there's better ways to actually approach it. So basically, we're going through each of these. We're going to loop, and our loop is going to go through each of these values, because and then when it comes to the empty collection, then, well, actually we can use our debugger to show what exactly it's doing. If I do put the debugger on here, so our collection is so we've got in here we've got our values for each collection. So we're looking to see if the collection is empty, which it's not, because we've set it to this 1, 2, 3, 4, 5. So that's false. So then we go on to recur. We get the rest of collection, which drops the first value. But then we're also grabbing the first value from the collection, 1, and then we pass both those values back into the loop. So now our collection is 2, 3, 4, 5, because it's the rest. But that's still not empty, so we keep going round. So the collection is 2, 3, 4, 5. We just want the rest of that, so we drop the 2. We get the first value from there, so we can keep track of what number we're looking at. That's 2, and we go round and round and round and round and round and round until then we're almost there. Collection's 5. We take the rest of that, then that's an empty list, because there's no more values in there. Our collection is 5, so we get the first of that. So our current value is going to be 5. Our collection's empty, so then this is going to be true. So then we just return the current value. So it's kind of quite imperative kind of thing, but it's a fairly simple thing to follow through exactly what it's doing. And then we just return the value. So we're done. But can we do any better? So we do have sequence functions. We have, as we've seen, we've got first.
I think we can do better.
And last. But we can't use last, unfortunately. Oops. And we've also got second. We can use as well. So is there a way that we could use not last, but can we use first to get that value? Well, we could use first if change the order of the collection. We got 1, 2, 3, 4, 5. We would just simply reverse this collection, and the last would now be first.
You looked at my answer, John.
You might look at my answer. I'm not sure.
Yeah,
it did flash up.
You never wrote first.
Did I not? I'm not sure what I did for the answer now. So if we reverse our collection here.
So that's what they should have made the restriction, not just last, the reverse as well. That would have made it tougher.
Well, that would make it harder, and then it would have made more sense to do the just do the loop
Do the
recurve
stuff you did. Yeah, exactly.
So if I reverse, you can see that, yeah, we've got 5 is now in the first position, so we can then simply just do first around there, and then, oops, and then we just slurp that in. There we go.
Is there no function that says loop that many times? Like not function, but like, you know, over here, you only know when to return to it when these conditions are fulfilled. But what if I want to say loop X number of times? Because it could have been used as loop the length of the sequence and then loop one less and then just read that and then you're done.
Yeah, I mean the loop in here is kind of like is based on one of the properties of the things that we're defining. So these are local variables that we're defining with inside the loop. So you could use any of those, or you could get all really fancy about how you control and how you break out of that loop as well. But yeah, it's a very manual kind of process of doing that. But yeah, so first reverse does give us the right answer as well. And there's probably other ways of doing this as well. But yeah, I did think of one, but I've forgotten it again already. But we'll leave that there for now. So what did I put in for my answer? That's a good question. Did I do anything different? Let's have a look. Oh yeah, so first reverse, all I did was just, so I put this into a function. I put it into the syntactic sugar for a function definition. So I've got first, and then it's going to take the first from whatever the result of doing this is. So pulling in the argument, which is going to be our collection. So it's going to reverse the collection here, and then from that it's going to take the answer. And this is working regardless of whether this is a number or a string. Again, Clojure doesn't care. It's just reversing the values in the collection. So it's just treating them as values. It doesn't really care what type they're actually in there. And I get a Clojure golf score of something fairly decent, I guess, 18. And in terms of solutions, I don't know if there's anything. Oh yeah. So comp is just another way of writing this, basically. So comp is going to compose the result of one function or calling one function. It's going to pass. It's basically going to call reverse and then pass the result of reverse into first. So it's kind of, I think it's kind of, once you understand comp, it's kind of nicer syntax. It's more elegant syntax than writing this specifically. This is a little bit lower abstraction than using comp. And when you start using comp very naturally, then you know you're kind of like moving up the hierarchy of abstraction in Clojure. So that's quite a nice solution, and somebody's used the threading macro again to do something fairly similar. So the threading macro is going to pass this value or resulting value from a function call. So this is so it's going to pass this argument through reverse, and then the result of reverse with this argument is then going to be passed to first. Normally you would write those on different lines, but I guess that's, so you'd normally write it this other way to make it a little bit more clearer. So let's paste that in there. So you would pass, oops, I've got grumbles. I didn't have breakfast this morning. So let's do enter. So sometimes writing this sequentially, although it's still functional code, you can read it sequentially, and you can also even comment these things out if you use the reader macro. So if you do that, then this would actually just call first on this. So if we pass in the collection instead of the placeholder, we can see the difference. There we go. So if I call this, it's just going to return 1. Oh, actually, sorry, I'm not calling that, am I? Let's do. That'll work. There we go. Yeah, because I don't need it to be a function definition now because I've explicitly given it the argument. That gives it 1. If I put the reverse, if I uncomment that, then I get the answer 5. This is also a nice kind of way to kind of debug and switch off parts of your code as well. So it's a one way around with that. And if you've got quite a kind of nested set of functions, so like a function within a like function call within a function call within a function call within a function call, and so on, then actually sometimes putting them procedurally is putting them sequentially using the threading macro is quite useful. I do have a quick example of that. There you go. Just a little bit clearer. Yeah, so here I'm creating a new sequence just by using a regular expression. Then I'm going to map lowercase over the result of that new sequence. And then the lowercase version of that, I'm going to remove the common English words, which is another call to this function here, frequencies, and sort by value and reverse. And so I can test each one of these functions individually running on book to see what the results are, and when I want to kind of get the overall processing thing, I can obviously uncomment them all out. So it's a nice way to show.
It's very clean, actually, and very readable.
Because otherwise, these would all be you'd be putting reverse would have it would be reverse, then sort by value, then frequencies, and then remove. So you're actually reading it in a sequential order, whereas when you write it, the reverse would be the outermost function, and then inside that there will be a sort by, and inside that will be a frequency, and inside that will be remove values. I might be able to do a. Is that? Ooh, that didn't work. Let's try that again. Am I running? Yes, I'm running a REPL. There we go. Let's try macro expand all. Oh, that's a shame. Oh, I haven't evaluated. That might be why it's not working. There we go. So if you macro expand, you can actually see. Oops. You can actually see this. What this any macros which the threading macro obviously use. You should be able to see the resulting code that it generates. Let's see if that works. Oh, yeah, sorry, it's doing book because I've commented it all out. There we go. Let's see. So let me just uncomment all these out. There we go. We can see that. Oh. There we go. That's what I was looking for. So yeah, so that's how you would write it in the sort of classic Lisp way. Which, if you're used to reading Lisp, then it's not too bad. You would start reading it from the inside out. Basically, say, well, what does that do? And then what does that do to that result? And then what does that do to that result? And so on and so on and so on and so on, and read all the way back. But yeah, there is some advantage in having it like this for certain things. So usually kind of like top level like namespaces where you kind of overall control of the application, what it's doing, it can be quite useful. Alrighty, let's close that window. Let's close that buffer for now.
John, what's the difference between the single arrowhead and the double arrowhead? I know you mentioned this some time back.
Yes, so here we've got two arrowheads. So it's kind of and then there's also the single arrowhead. So it's just where the value is placed in the next line. So with a double arrowhead, then this book is actually placed here. So it's like I would call this resig function with the book in that position. If there was one arrowhead, then it would be the argument of book would be placed in here. So it's like the single arrow is at the start, so it's the first argument, and double arrow is the last argument. And you can mix them a little bit as well if you need to, but yeah, it's better to just kind of stick to one or the other if you can.
Is there any use for this? They must have had an idea behind putting this, right? Because we could have just had one way of doing this and be flexible in where you put the inputs.
Well, I think it's because Clojure, unlike some other functional programming languages, Clojure is quite happily using multiple arguments. So some functional programming languages just like to use like a single argument to functions. So to give some flexibility in like a pragmatic approach, then if you've got different places can also mean different things in functions as well. So if you're doing like a conj, then there's a definite place for where you put the collection and then the value that you're going to join to that collection. So some functions have a specific ordering that they need, and so if you're going to allow that flexible number of arguments, then you need a little bit of flexibility in doing something like this with the threading macros. Yeah, so I think this gives a nice flexibility because it's either at the start or the end, and that covers like 90% of all the cases you ever want to do. And if the thing that you're passing into the next line is the only argument, then you don't actually need to include any brackets around here as well. So this is still a function call. This is still going to get evaluated into so the frequencies is still going to have a bracket around it, but because it's a macro, you don't need to include the bracket when there's only one argument. Here we're going to have two arguments because it's going to have common English words and the result of this map. So that's going to go into there. So this is going to have two arguments, whereas frequency is only going to have the one argument, so you don't need to put the brackets around it. So some people prefer this because it looks, as you say, it looks cleaner. Okie dokie. So let's maximize that and then get rid of the buffer. Kill it anyway. Yes, I do. There we go. And maybe we've got another time for another one or two. Let's see what we've got. So we've done 19. So let's look 20. See what that is. To Fibonacci. Oh, that's 20 solutions. No, we don't want to look at the solutions. We want to look at the problems. There we go. 20. Penultimate element. Oh, the second to last element. Well, this is a little bit, if we can do the same kind of looping around there, but then we need to figure out whether there was only one element left in the collection. So with the loop here, we could lose that. And so instead of it being empty, our condition was, is there only one value left in the collection? And that would still work. Although we can also use this little trick here, so we can still reverse it, but instead of first, we can use second.
Oh, you got my answer again, John.
Oh my God, how did I do that? Oh, look, I didn't even write it as well. So yeah, here I've done something slightly different. What have I done? Oh yeah, so here I'm doing the count. So I'm counting how many elements there are in there, and then using nth just to get something that's the position -2. So it's -2 because they're going to have an index. And the index is going to start at 0. So if you've got a count of 4, then the last one is at position. You've got like 4 positions. So the last count is at 3. So that's the position you need to get. So, but I think I actually like the reverse better. It's a nicer solution there. I don't think there's any other ones that just check that works. I don't know if that's any. I think that's not even a better goal score either. Oh, there we go. And somebody else has used but last. I don't know what but last is. I haven't come across that one. That's interesting. Is that a thing?
Oh, I didn't think there would be a function like that.
It sounds a bit weird. I'm a bit trepidatious about Googling for that one. There we go. But last. Returns the sequence of all but the last item in the collection in linear time. Yeah, interesting. Okay, so it's so I guess it's the corollary to rest, but it starts, so it gets everything but the last one. Yeah, interesting. There we go. And then this is doing kind of reverse rest, and then you can get the first from that as well. Yeah, because the rest will take off the first one. I guess you could just do comp second. That would be, oh, there we go. Yeah, comp second reverse. Yeah. So that's probably the nicest, simple, kind of highest level abstraction there. So if you're doing that one and you're comfortable doing that one, then you know you're on a good thing here. So yeah, and here it's just checking whether the count is equal to 1. So that's the same as so this is a low level approach to doing that low abstraction level. Pop peak. So pop and peak are ways to access collections that are quite efficient as well. So if you're dealing with large data sets, then pop and peak might be the ones you go to, but for kind of these modest size ones, then there's not really much advantage in using those. And that, what is that? Oh, I suppose that's a looping function, because so we've got a function called this, and it's basically just going to call itself with the next value from that. So this is a loop.
There's a lot of rests there and firsts and nexts.
Yes. So this is like quite like messy, quite dense kind of Clojure to read. It's very explicit, but yeah, it's not. There's nicer code you can write around that. So yeah, compared to this and this, then once you get used to the comp function, then this is going to be much nicer to work with in the long run. Yeah, that's about it, really. I think. Yeah. Boom, 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 boom. Nothing else more. Yeah, I quite like that. I'm going to put that back in. Oh, I'll leave it for now. So let's have a look. We've got time for a couple more, I think. It's 21. Let's have a look at that. See what's that one.
This one looks a bit tricky.
Yes. Nth element. Write a function that returns the nth element from a sequence. Have I solved this yet? Oh, yeah, I've dropped that one. Yes, I've done that one. Yeah, it's a bit more interesting. Write a function which returns the nth element from a sequence, but we can't use nth. So that's a shame. So normally you could put nth in here, and nth takes the collection, and then not the value it's looking for, but the index. So the index here, so would be 4 would be at index 0, 5 would be at index 1, 6 is at index 2. So it's looking for the index value here, but that we can't use nth. So we want something that works like nth. And let's have a look. What am I? Oh, there we go. So here I've got a function as my answer. So I'm putting a function in here. It's going to take the collection, and then it's going to take the number, and it's going to do, let's have a look, so drop. So we're going to drop the number from the collection. So let's have a look, see what we did here. Boom, boom. That's the wrong. Oh, there's the right. Okay, so let's have a look at drop. What does drop do? Drop, and we've got a collection. What do we need for drop? We need a number or a collection, or a number and a collection. So let's do drop 2, and then our collection is collection is that. Actually, I'm going to just get the numbers there. Numbers, and I'm going to put that into a vector. And there's my numbers. So if we drop 2 from that, do we just get 6 and 7 from there? I suspect we do. Yes, we do. So it's dropping the first 2 numbers. So this is like this is interesting because that's using like an index of starting at 1 rather than starting at 0. So it's just using the amount of elements and not the actual index of those elements. So if we drop 6 and 7, we drop all the values that are before the collection, before the number that we actually want from the collection. Then we can just get the first number because that will be the result. We're just adding first to this, and then we slurp that in, and boom. So that's what we're doing, and we're just putting it into a function so that so we can actually run it in place in our code. Oh, there's a question there. I missed that one out. The solution I did for the last element, 4Clojure is doing. Oh yeah, yes, yes. I do like the comp first reverse one. That's quite nice approach. Yes. So this one's fairly. Once you start thinking differently about it, because we're not trying to iterate over this thing. We know the position we want to go into, and so we just get rid of all the information we don't want, and we have a position of the values we do want, and we just grab the first one because we know it's that location. So we're using the sequence functions and just adding drops. It makes it pretty simple kind of approach, and it's fairly easy to read. So sometimes you just have to sit back and instead of trying to recurse over something, say, well, what's the information we actually want? What information is useful? Try and get rid of everything else, and just make it nice and simple for your functions to get the information, really. So I get in a sense we're doing some pre-processing of the collection with drop, and then the result of that makes it really easy to get our value. Is there any? I could probably get a smaller golf score if I did collection and number as just single characters. Obviously, that would make it less readable in actual code. Oh, 51. There we go. So I could put like a C and an N instead of there, and a N and a C there, and it would make it shorter. But again, it's only a golf score. It's not important. There we go. Yeah, so that's essentially the short version of mine, a slightly less readable one. Yes. I don't think there's anything.
I got a slightly shorter version than yours.
Ooh.
I think mine is you just scrolled by. It's first drop percentage to percentage 1 as a function.
Okay.
It's that one below. It's hidden by that one there. Stop
in
the middle. Yeah.
Yeah.
Well, I took the inspiration from your drop and I changed it around.
Oh yeah, thank you very much. Yes.
So
this would be okay. Yeah, if you're.
Oh, vec. Oh, look at that.
Oh yeah, interesting.
What is vec? Oh, so you're telling this position in the vector? Is that how it works? Give me this position in this vector.
I'm not quite sure about that one. Let's have a look at that one. Well, that one's a bit longer. There we go. Let's have a look at vec. So if we put that into a function call, let's see, that's there, and I want to slurp that. Oops. In, oops. And then let's put our value in as well, so we've got something to look at. Data, test data to test. Did I do something wrong with arguments?
Yeah, brackets.
Yes, what did I do?
You need another argument. You need to say which position, right?
Oh, yes. Good point. Yes. And that goes after there, doesn't it? Yes.
Yeah, it's percentage 2.
Yes. And then it's 2. Yes. Thank you very much. Programming. See, it's very useful.
Mm.
That's giving us the right answer. How is that working then? So what
0, 1, 2. Yeah. So I think vec is taking the whole string and the percentage. Oh, it might be. Oh, wait a second. In that case, you can just say. Oh, I think you can just say. No, you can just put that in the box. Yeah, put that whole thing in the brackets and put 2, and it probably gives an answer. Remove the vec. I don't think you might need to put vec.
Yeah, I'm not sure what vec, because I don't think vec would do anything really, is it?
No, vec is converting that construction into a vector.
It's already a vector, isn't it? So, oh, I suppose. Oh, yeah. Okay.
And then you just say percentage, and you just say 2 of it. So it's 2 is probably working as an index on it.
Yeah. So if I go back to. Oh yeah, because some of these are not vectors. So it's obviously using the property of vector. So it's using the property of a vector. So obviously this is a list, so we need to change it to a vector first.
I just tried it. It works. If you just put percentage, actually, you didn't even need to put vector.
Yeah. Yeah. So well, percentage 2 is the argument. This is the second argument that we're getting. So this is basically 2. So the %2 is a placeholder for the value 2 that we're passing in as an argument to this anonymous function. So yeah, so vec on itself doesn't do anything. If we change this to a list, cycle that to list, and then obviously quote that, then now that makes sense. Running vec on this makes sense because that turns that into a vector. But yes, you can take a vector as a function. So if you have, we're going to call a function, but in this case, the function we're going to call is the vector. So it's like 4, 5, 6, and 7.
I pasted a solution in the video chat. You can see it's even shorter than.
So this is so we've got a vector here, and we can give the vector an argument, and it's going to say, okay, look up, return me the value that's at the index of 2. So this is like we can use a keyword to look up things in a map, or we can use a key to look up things in a map. We can also use the index to go and look up things in a vector. But obviously it needs to be a vector first, and not everything was a vector, so we do that vec conversion, and then we add, and then once everything's a vector, then we can just use the index to go and look up the value. So this will just return 6 as well. So that's quite a nice usage of the collection as a function, which we give an argument. In this case, because it's a vector, we give the argument of the index that we actually want to return.
Doesn't work on a list, though. I just tried.
Well, that's why they have this vec in the solution. This is what this vec is for.
So it could convert anything into a vector and then work on it. Got it.
So without that, the first one would, so this one would fail, and this one would fail as well. So this is being converted into a vector.
Got it. Yeah, my solution won't work for.
It will. Oh, it's not far off. Yeah, you would need.
No, but it won't work for vectors.
Yours does the yours does the kind of real meat of what we're looking at here, and again, the vec is just preparing the data.
Yeah.
For us to run that simple function of just using the collection itself as a function. It did take me a while to actually get used to actually using a collection as a function call as well. So, but yeah, it's any collection can kind of knows about itself, so you can ask it questions about itself. That's how I think about using a function, using a collection as a function. Alrighty, well that was a fun one, and time for one more. Let's do one more. 22. Let's see what the next one is. Practicalli Sequence. How do we count a sequence? Write a function. Oh, but we can't use count. Oh, they're really being cruel to us, aren't they? Because obviously we could just use count for these and they'll be very easy. What did I do as an answer? Oh, I reduced. Oh, yeah, this is quite a fun one. Yes. Any ideas how you would do this, Manny? Not putting you on the spot at all.
Of course, not putting me on the spot.
Yeah.
Given that there are only 3 people in the room.
Yes. Oh, thank you, Connie. Connie is sending us greetings, good Christmas greetings. Thank you, Connie. Hope you're finding this useful. Yeah, so this is a little bit tricky. So I did some lateral thinking with this one.
Oh, lateral thinking, John.
Lateral thinking, yes. Otherwise, I thought, well, okay, what's so how do we know how many things are there in the collection? So we obviously can count them, but
I think you can ask the collection in a different way, isn't it?
Yeah. Boom, boom, boom. Yes. I mean, we could look at the count. We could look at the source code for count. That's a perfectly valid thing to do. So we could go in and go into count.
Has somebody put the source code for count public? I'm joking.
Yes. So it's all on GitHub, strangely enough. It's all open source.
And all of it is written in Clojure. Ooh.
Actually, not all of the Clojure core is 100% pure Clojure. There's quite a little bit of Java interop for performance reasons, and wherever the host language actually has stuff that works really well, then we just use them. So some of the types we'll actually use from Java. But yeah, it's all kind of abstracted away when you just use the Clojure core itself. You don't need to know it. So sometimes you'll go in and the source code for a function is quite nice and simple to read, and sometimes it's like really like scary. So like definitive less than is not too, that's pretty nice and clear. But the count is not that nice because it's calling another count function on the collection, so it's actually just a wrapper around count. So then we'd need to go and look at that as well. So it's not a very useful one to give us any hints about what we're doing. And we can also look at count and see if it suggests anything. Is it counted? I don't know what that does. That's weird. I haven't come across counted before. What does that do? Returns true if call implements count in a constant time. Interesting. But that's not going to help us in the bounded count. So there are some, lots of different variations on that by the looks of things. But if we go back and think about this, well, what if all of these were 1? If each of these values, if we had a collection of, let's go to the next one. So this is 21. Divider, number hash 21. Oops, no. So if we've got a collection here of 1, 1, 1, 1, 1. How could we count up how many there are? Well, that should be fairly easy because we could just add them all together and then we get the result.
Yeah, but it's only because if there were 1, if there were strings and there are odd numbers, it wouldn't work, right?
Yeah, so we could reduce by adding all these up and then oops, I missed the button there. So if we add all these up with reduce, then that's going to give us 5. Is that right? Yeah, 5. So there's 5 things in there because they're all 1s. So that's a really easy function. Is there an easy way to convert all these into 1s? And then we're kind of done. that would be quite nice. So I think that's the approach that I took because of this. So basically, yeah, switching it on its head, rather than trying to kind of iterate through each of these and counting them all, which is, I mean, it's not too difficult. Iterating through those is fairly easy. You can just write a loop to do that. Same with string. You can, because a string is just a collection of characters, so you can walk through the characters and see how many there are. This one, again, is not that difficult because it's counting the elements of the outer vector. So this vector is has vectors inside them, but we don't need to count how many things are inside each of the vectors. We only need to count that there's 1, 2, and 3 vectors. So that's not too difficult to iterate through either. There's only one thing in there, so that's fine. And the same thing with that. So it wouldn't be too difficult to write a loop to kind of go through those things. However, I took a kind of sneaky thing because there's this thing called constantly, which is quite quite unique little function. It basically just returns a value, whatever you do with it. So if I map constantly over something, it's going to return a value of whatever I decide. In this case, it's going to return a value of 1. Go back to our map here. And let's see, so let's paste that in, and let's do, well, obviously 1, 1, 1 isn't going to be very helpful, but let's do this, for example. So our argument is going to be does that work? Oh, map constantly. That's. I got too many brackets there.
I have another solution, but why don't you do yours? We can compare. I think we are going slightly different directions.
Oh yes. Oops. Well, there's a rookie mistake. There we go.
Rookie mistake.
Rookie mistake. Why is it working? Because I missed my comment. I missed my quote out there. There we go. Of course, it's trying to call for as an argument, as a function. That's not going to work. There we go. So if I use constantly, then it's basically replacing all the elements with a 1. If we take the other arguments, let's say if we take this here, it's a bit more interesting structure, but still it should work the same. So if we do map constantly, and then we get rid of that, and I don't want that. Yes. I must be wary about copy pasting things because you do end up with unexpected items in the bagging area. I know it's unexpected. Let's just switch it off and we can delete that. There we go. I basically just switched off my safe structural editing just so I can delete that. So now it's going to return a 1 for each of the elements inside the outer collection. So it's for each of the internal vectors, it's just going to replace those with 1 as well. And then when I just add them up with reduce plus, then I'll get the right results.
How are you going to deal with hello world?
Well, oops. Hello world is just the same. So hello world is a string, and a string is a collection of characters. So when we map something over string, then because we can map, let's see what we got. So we can map a function. Let's do Clojure. Strings probably got something interesting we can map over there. String. And then, oops, so has that got an uppercase? There we go. And if we pass it a string of hello, then does that give us the string back? Wow. So that shows you what it's doing with the string. It's actually breaking it down. The map is breaking it down into individual characters. So it's treating the string as a collection, just like a vector or a list. And so each of the characters in the string are elements in the collection. And so when we map constantly over the string, constantly over a string, then it will do the same thing there as well. So if we get rid of that and we put in a string called hello, then we should get one for each of the characters in there. So then all we do is add them up, and we have a possibly quite sneaky way of solving this problem. It depends on your viewpoint on how sneaky it was.
You've got a sense of humor today, John.
I am. It's holidays, isn't it? So yes. So when I run that, they'll pass. I get golf score.
Been having a holiday for a long time.
Yes, I shall be an employee in the new year at some point as well. So yes. There we go. So yes, not the best. It's not the lowest score, but I think that's quite a nice way of solving this challenge, and quite an interesting approach to kind of using, because these are all using just the functions from the Clojure core and using abstractions that people have defined for me already. So it makes the actual processing of this. So map is fairly familiar. Once you start doing Clojure, you get used to using map, to mapping a function over here. And regardless of what we're doing, so again, constantly using taking any arguments from the collection we're giving it to it. So it doesn't bother taking any of these arguments. It's just basically purely whatever map pulls out from the collection, it's always going to just return 1. So it doesn't really care. So it doesn't need to look at any arguments. It's just going to return the value 1. And I think that's quite an interesting way of solving this problem, if nothing else. Boom, boom, cool. And then Connie's just gone. Yes, thank you, Connie. Thank you for joining in. And
you scared her with all the nth source code and the count source code, I think.
Maybe. I'm sure she's got plenty of other things to do.
Oh, it was boring.
No, it sounded like she enjoyed it. So there we go.
I think she enjoyed it, yeah. Yes. I kind of used another way, which I don't know if it'll work everywhere. I'm going to paste the solution. So you can use something called index of. You must be aware of that.
Okay.
And so then you can do something like this, last. So you do last of a vector of the input. So everything will be converted into a vector, whether it's a string or a vector or a list. And then you do a last of it, and you then do index of. The only place it'll fail off is when there are non-unique values. Sorry, non-unique values in the string, and then it might just pick the wrong one.
Okay.
So
interesting. Yeah, but yeah, you're transforming everything into a vector, and then
everything becomes a vector, and then you do a last of it.
You do last. Yeah. Okay. Interesting.
And then you can do an index of the last.
Yeah, I like the approach. That's quite nice.
It's not fail-proof though, but that's what I was worried about.
Yeah. This one's quite interesting. It's quite low level. This one, it's basically so it's using some of the implementation features basically of these things. So it's seeing whether something is an instance of Java util map or collection or char sequence, and then it's using size or length. So there's obviously some differences about how these are implemented. So yeah, so some things are in Java util, some things are Java lang. So obviously there's a slight difference of the underlying representation in Java of how those things are actually represented in Clojure as well. But oh yeah, somebody's got the same as there. That's quite nice. Yeah, I think this was not a this wasn't the first solution I came up with. I think I did try and yeah, iterate a little bit through there. But yeah, I quite like this because I think this is one of the things I thought about on the ride home from a dojo when we were doing this exercise.
Oh, cool.
Yeah, so sometimes, so yeah, I appreciate this is not one that just instantly. Oh yeah, it's obviously do this because it's not. This is not an obvious solution to it, but it's.
It isn't. Also, the readability
nice approach.
Yeah, the readability of it is like if you immediately see it, you need to think on what it's doing. Because if you don't know it constantly does,
yeah,
then because that's where it's hidden, right? No, I pasted my solution, which isn't foolproof, but it does.
Oh yeah.
So it does an index of the last of the vector.
Okay.
Which kind of works for many cases, but I don't know if it'll work for all the cases. So what is yours doing? Reduce of what was that? What was your solution?
This is a different one. So mine is reducing. So it's basically just converting all the elements to one, which is this, and then it just adds them up. Because they're in a collection, then it obviously has to reduce. Either use reduce or apply.
Okay, yeah, makes sense. That's always going to work.
Yeah. So
can you give it anything?
Pretty much, you can give it any collection. This will take any collection because the collection has elements. So any collection, including a string, as a collection as well, because every element will just be replaced by whatever value we set for constantly.
Yeah.
So yeah, and then obviously if we're just setting it to 1, then we can count up those values there. And that's what we're doing there. So this part is transforming the data, so we can actually just have a very simple function, and our simple function just adds the number of ones up. So it's quite yeah. This is a very kind of lateral way to think about it.
Okay. Yeah. Reduce plus. Yeah. Map. Oh, I can now think about it. Constantly 1.
Yeah.
So
there's some interesting things you can do. I mean, a lot of people use things like identity to break things up as well, and there's a few more things we'll kind of come across in future broadcasts.
Yeah. Oh, that's interesting.
Right.
So if you didn't use constantly 1, what would happen?
It would just you'd need some function there. If you just did identity, it probably wouldn't be very helpful, I think, because you wouldn't.
Yeah, I tried identity, and it went in an infinite loop. Don't know what that means.
Yeah. So we're substituting each of the elements in here with 1 essentially. So we're basically taking our immutable data structure and then creating a new one that represents it, but represents it in terms of how many elements are in there. Because each element of this is just going to be turned into a 1, and that way we're kind of representing the structure of that collection, and not the values in that collection.
Not the values in the collection. Yeah.
And then we can just add, because they're all 1s, we can just add them up because it's representative of the structure, and that kind of shows us how many things are in count.
In a way, you're just doing a repeat of 1 as many times there are elements in the structure.
Exactly. Yeah. So it's basically saying whatever element it is, just replace it by 1 essentially. Because map is extracting each element in turn, and then constantly says, well, actually forget the actual value and then just substitute it with 1. Just keep this result, the result of calling this function, which is always 1, and then so whatever value map is pulling out, it says, okay, I'll run constantly 1, which is just going to give us 1, and then boom, we're done. Cool. Alrighty. Well, I think I'm going to leave it there so people go off and enjoy their rest of the weekend. There's at least another 130 odd 4Clojure problems to solve. And yeah, the next few are quite interesting as well. So we've got reversing a sequence.
Without using reverse.
Without using reverse, so that makes it more interesting. There's summing it all up. What's that one like? Was that complicated?
You could use your constant solution there, map and.
Yeah, that one's probably a little bit easier. They're all collections, so that might be quite an easy one. And 25 is, what's that one? I think there's the odd numbers. Yeah, that's relatively easy. You can probably use a filter for that one. And 26, I think, is a more interesting one to have a go at. So I think it's Fibonacci Sequence. Well, there's my solution. Did you see it? Oh, there we go. So I don't have a one-liner for that, but
Fibonacci should be like one-liner.
I think actually, I've done.
It should be 3 liners.
Yeah, I think I've done a new version of that, which is a bit more. Which is a bit more. Yeah. Okay. So yeah, I'm looping around stuff. I think I did come up with a nice solution for that, but I'll cover that in another session. Alrighty, thank you very much for everybody for listening, and I'm going to leave it there. Again, just another reminder, if you want to see the Advent of Code stuff, then I recommend going to Tim Potes, which is twitch.tv, Tim, P-O-T-E. I'm going to look through some of these at Christmas, and there's also this, if you want to contribute to open source, there's 24 pull requests, which is a very nice website, which encourages you to, do some pull requests to your favorite open source project. And it also lists a whole bunch of projects as well. So if you want to find something to go and contribute to, then it's a good one. And you can add your own projects that you want to go and contribute to as well. And every single pull request you do between like the 1st and the 24th of Christmas gets counted, and there's a little scoreboard, a leaderboard kind of thing there for there to just to gamify it all. But it's a nice way to get you into doing pull requests for open source projects that you're using every day. And obviously then there's also the Advent of Code stuff to go and play around with as well. Hope you found this enjoyable, and I will see you next time. Thank you very much. Goodbye. There is it. Stop broadcast.